Now let's combine the two main ideas from the previous videos. So we know that if x is, how do you say, a binomial with parameters n and p, so again, this is, you can think of it as tossing n coins with probability p of heads, then and here heads is considered a 1 and the tails is a 0, then the expected value of x is going to be n times p, and the variance is given by this expression. And we also saw Chebyshev's inequality, which says that the probability, so if you put this into the Chebyshev inequality, it's saying that the probability that x is a certain distance away from the expected value, so this distance being t, is going to be less or equal than the variance divided by t squared. So as t grows, this should be more and more likely that things are close to the average. So let's write this out for the fair coin example. So for a fair coin, so that means p is equal to half. And so what that means is that, so the expected value of x will be n over 2. So you expect that around half of them will be heads. The variance of x will be n over 4. And then Chebyshev's inequality is telling you that the probability that x will be far, let's say, from this average of n over 2, so the probability that this happens by a distance greater than t is going to be less or equal than n over 4t squared. And so let's copy this. And let's look at some numerical examples. So let's say that we are going to toss the coin 100 times and that the probability is half. Well, then the n is equal to 100. So I just need to erase here, 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 and here, and put 100 there. So this will be, actually, I can do better. 100 divided by 2 will just be 50. 100 divided by 4 will be 25. And so this will be 50 here, and this will just be 25 over t squared. And let's look at some particular examples. So if t is equal to 10, then what we're saying is, let me copy paste this here. What we're saying is that this probability here, which we can paint in green also, being larger, let me move this a little bit forward. Okay, so if t is equal to 10, then this probability here of being larger or equal than 10 will be 100 here, which is equal to 0.25. And so what does this mean? This means that if you're tossing the coin 100 times, and 1 is a head, so you're counting the number of heads that you get, and so let's say that this is from 0 to 100, and of course you have your expected value at 50. So now what this is saying is that the probability that this is large, that the distance is larger than 10, so what would be 10 here? So 50 plus 10 would be 60. 50 minus 10 would be 40. And so this is saying that the probability that you get a number of heads in this region here, so outside of that, so this is the probability that the number of heads that you get, the distance from 50 is larger than 10. So it means that it's either in this region or this region, is a 25%. which means that there's a 75% chance when you toss 100 coins or 100 fair coins that they're going to be in the range 40 to 60. We can also then replace here. So let's copy this and put different values here. If you were to increase this to say 20, let me change all these values. And here also. So if you were to do t equal to 20, so this will be 20. So now it'll be 20 squared here, so this will be 400. And this is going to be equal to 0.0625, so that means like 6%. So that means, and distance 20 from 50 would be like a 30 here and a 70 here. And so the statement would then become the following, that what is the probability now that if you toss 100 coins, the distance from 50 is larger than 20? That means that, let's say that you get less than 30 heads or more than 70 heads, that's going to be around 6%, which means that it's like a 94% chance when you toss 100 coins that you will get between 30 and 70 coins. And so you see that this goes very quickly because this t here is going like the t squared. So although the t is growing linearly here, if you increase it, it'll go quadratically here.